Hello, everyone. Welcome to another episode of the Day Zero podcast. I'm Spectre. With me is Z. We are a little bit late on this one, as it was Thanksgiving weekend in Maple Syrup Land here. So
We should have just
we were a
recorded
little
over the
busy.
holidays. Who cares
Should
about
have. I mean,
holidays? No.
we have in the past, but
We
this
have.
year I was fairly busy.
Yeah,
So
in the past we have just kind of like grinded right through. Like, oh, it's a holiday. What? I'm just going to keep going. But no,
yeah,
I think this week our timing just kind of got messed up with recording episodes in general. And yeah, but I had a good
yeah,
Thanksgiving, so worth it.
yeah. Same here. And hopefully our other Canadian friends out there also had a good Thanksgiving. So yeah, we are a little bit late, but we're here nonetheless, and we have a few things to talk about. One of which was a little bit controversial and generated a bit of drama, and this caught your fancy, Z. And it was an issue around a vulnerability that was found in Zendesk, which is used by a lot of major companies. So Z, I'll let you get into the details.
Yeah, and so the bug itself, it's a fun issue. If you're familiar with the old, I think it was like 2017 ticket trick, this is basically that, like same principle, slight update on the attack itself is one thing. What I am going to want to talk about though is really the handling of the bug bounty here, and just kind of get annoyed with Zendesk for a bit. But talk about the actual issue. So like I said, it's kind of fun. It does tie back into ticket tricks. A ticket trick was basically just the idea that you would go, and let me pull up or at least I assume this is where it originated. It's the first time I remember seeing this bug. Whole idea being like, ticketing systems or any sort of open mailing list, but ticketing systems often are just that sort of system where you send an email to an address at the company, and then you're able to, if they have like a public ticketing system, anybody can see the contents of that email. Of course, it's being sent to support, like it's intended to kind of be a public sort of thing in those cases. But what somebody realizes, well, okay, so that email is like, support@company.com. Therefore, if you go and try and register on like, Apple or Google or something, you can then get an account at like support@whatever.com, because it's going to send the email to the support desk. And then you just read it out their, public help desk or mailing list is another thing. This attack talks about a few different options. I think they start off with, issue tracker. And they use GitLab's issue tracker as one option. Emails being sent there. I think they actually do even use, they even use Zendesk as one of them, the support desk. Really just anything that has that sort of email interface. You can then get the verification email and kind of create an account. And then from there, like you link that account onto like Slack is the classic example that'll get used. You link that into Slack and you get access to like all these internal Slack channels and kind of attacks at that level to get access to internal things, because you have an email with the correct domain, because so many things just rely on that domain being correct. So fundamentally, all that happens for this bug here is same idea, except even if the full ticket system isn't public, they basically abuse being able to CC somebody in on those emails. With a ticket, if you were to CC somebody, Zendesk would just go ahead and say, oh, this person is supposed to have access to this ticket, so let's give that user with that email like access to the ticket now. And that just like, the ways, if you're not familiar with Zendesk, the way Zendesk work, or one of the ways they do have multiple interfaces, you send an email to support, and when you get an email back and you start replying back and forth on that, it'll have like a reply to address with a ticket ID in that email address. And so you can reply to that address and it automatically gets associated with the ticket. So when you do a CC on that from like whoever made the ticket, it'll be like, okay, we can add this user. The problem is kind of twofold. One is that IDs are predictable. So the IDs are just incremental, like ticket 1, ticket 2, 3, 4, kind of incrementing like that. So you can predict what the next ticket will be. Just create a ticket, see what your ID is, and get the next ticket, and then like do the attack with the next ticket ID. And the second part of that was that you could use email spoofing to impersonate that original sender. It didn't do sufficient checking on the emails. Oh.
I
And
believe they
that's
say at one point that they weren't properly observing the like DMARC scores and whatnot. I don't
kind
remember the
of,
exact
yeah.
quote.
I'll touch on that because that gets into the fix. Yeah, they were
Right. Okay.
using two different scores, CloudMark and RSpamD. They were using these two different scores, and they kind of talk about that when it comes to Zendesk fix. But kind of getting with the actual issue just comes down to the fact that Zendesk wasn't sufficiently checking that the email was legitimate. When it comes to the DMARC stuff, that's where the problems start on this. You've got the H1 analyst who gets this report in because they find this bug. Oh, you can add yourself onto like any ticket. This seems like an issue. It's could be privacy. It's kind of leaking the whole
It's like
information
PII
that the
disclosure. Yeah.
yeah, you've
Or
got that
potential
aspect,
for it at
but
least.
it's like the whole purpose of Zendesk, if you're not running this as a public system, is the fact that those tickets are kind of private. Like that is the only data they're really protecting. And so the ability to add is kind of like big for the application. However, it got rejected as out of scope because it depends on a SPF, DKIM, or DMARC issues. And that's one of those lines that is like one of those out of scope entries in like so many bug bounty programs, really because people go around being like, oh, you have a bad email policy, therefore, alignment, whatever. Therefore you could potentially have spoofing and like it's an issue. And it's like one of those throwaway lines. But because of that, this analyst seemed to look at this bug report and was like, oh, it has email spoofing, therefore it must be this. And I don't feel like they actually understood the core issue. Just because there's multiple ways you can kind of interpret this bug. We do kind of know more about how Zendesk work given one of the answers, but this sort of bug, like, this could be a fault on the client. This could be the case that whoever is setting up their Zendesk server should be enforcing like all of these things and checking for any sort of spoofed email, and like that is on the client. However, I think for a lot of people, like they don't want to throw away potential support tickets, and so they're going to just forward all the emails over, and then Zendesk kind of takes that. And I will also say what actually happens here is that Zendesk does do checks on these emails to see if they are spam or not. So they are taking responsibility for doing this check. So that is thoroughly something that they're doing. And, they had a failure here. That said, from the outside, I was trying to look at some of their documentation. I couldn't find a lot that actually documented any of these issues. Anytime you find like the DKIM DMARC mentioned in Zendesk support work is purely as here's how you set up your like outbound email so they'll always be signed and like set your SPF record so it all looks good and Zendesk can send them. It did not check for the reverse of that on making sure you're not getting incoming spoofed emails. So this does feel like it is a bug that should actually have fallen on Zendesk, but I think this analyst just kind of looked at it as this is email spoofing, therefore reject, and kind of just fell into that pattern. And I don't totally blame them because they probably get a lot of those stupid bugs. Like that is one of those classic bug bounty issues. Just send that off and hope to get a payment out of it. But also this report is probably pretty different from that. Anyway, so Zendesk closed this as being out of scope. They basically said, fortunately, this particular issue report is explicitly out of scope as outlined in the policy page. So fair enough, it's out of scope. So what do you usually do with an out of scope issue? I would argue it is completely ethical to then start reporting the same vulnerability on anybody using that platform. This is what you see when somebody finds like a bug in a library that doesn't have a bug bounty. You find the bug in this library, and then you report it on anything that accepts those types of reports, because things will sometimes indicate like if the bug is in the platform or in like the lower levels, that's going to be out of scope, but there are bounties that will pay out, and so you go to them and you get the payout on it. When the platform is rejected fixing the bug, that's really the only option. With Zendesk, the way I kind of would read this out of scope is basically, yeah, this is out of scope because it's the clients who need to set up that sort of filtering. Therefore, the clients need to fix their issue. Although that interpretation is incorrect, that is kind of the way I read this initially. What makes this worse, though, is like, after they did this, got some more bounties out of reporting this to people using it, Zendesk came back and was like, ultimately decided not to pay out any bounty and kind of gave this researcher a hard time. Actually, I'm going to pull up the Zendesk kind of response to this. One of the things they say here is, we also want to address the bug bounty program associated with this case. Although the researcher did initially submit the vulnerability through our established process, they violated key ethical principles by directly contacting third parties about their report prior to remediation. This was in violation of bug bounty terms of service, which are industry standard and intended to protect the white hat community while also supporting responsible disclosure. This breach of trust resulted in forfeiture of their reward, as we maintain strict standards for responsible disclosure.
Meanwhile, they weren't going to reward them in the first place.
Yeah, they already denied the bounty by closing it as out of scope. There was no consideration, so there's no agreement, there's no contract between these two because there was no consideration.
You really can't have your cake and eat it too and be like, this issue is out of scope, and then when people talk about it, be like, how could you do this? Why would you talk about it?
So
it's irresponsible.
You can, like, and bug bounty programs have done this.
Oh, but sorry. Okay, I should say you can't have your cake and eat it too and expect not to be criticized for it.
Yeah, like that's the thing. I will fully criticize this sort of behavior because they tied the researcher's hands. Oh, it's out of scope. The researcher goes to where it's in scope. Oh, you shouldn't have done that. Like, no, you made the decision that this was out of scope already. And they didn't go and report that same... They reported the same vulnerability, but I doubt they made reference or disclosed this bug in Zendesk. They reported it in a way that it was relevant to the actual vendor using Zendesk. They didn't have to go, oh, here's this other report.
Well, to be fair, I don't know if we really know one way or the other. I don't think we have enough information to really judge that.
And I don't think we can say, like, they obviously didn't link the original report. Yeah. But they absolutely did not violate any key ethical principles or anything of, well, okay, capital R responsible disclosure. They did, because capital R responsible disclosure puts all the power on the vendor to say this can be disclosed or not. That said, most people, when we're talking about disclosure these days, I feel like we've always kind of moved on to coordinated disclosure. That's where the researcher can also give like a timeline on, like, I'm going to disclose this in 30, 60 days or something. But no, they disclose this to those vulnerable after the upstream denied the bug. It is entirely ethical to do so. They rejected this bug. And the fact that they kind of doubled down on this, because I think they very easily could have handled this as just saying, we feel that this was out of scope because our clients should be enforcing like the DMARC, should be checking the SPF policy or something. It seems like they're doing that. They're taking responsibility for it, so they can't actually do that. But they could have tried to frame it in that sense. But by trying to frame the researchers' dealings here as being unethical, that just rubs me the wrong way with, like, as a program, because they're like, this is pretty standard. When a library has a bug, or a platform in this case has a bug, you can report that against multiple targets and claim bounty for the same bug. That's kind of how, like, a lot of people that have claimed like really big bounty amounts are because they've reported the same bug in multiple places. It's entirely accepted practice to do that. And so calling this guy out, especially, like, I feel terrible because this is someone who's like 15, I think they say at the top. So, some program experience, not a ton of bug bounty experience here. And so one of their early responses here is a company calling them out as being unethical and all of that. Like, that's just not a good program to work with. And so I kind of wanted to highlight and soapbox a little bit about that, because it really rubs me the wrong way when companies do that. And try and call things out as being unethical when they're the ones kind of acting unethically and trying to hide and not fix a bug.
Yeah, it's that classic case of trying to use a bug bounty program to suppress any discussion of something, because if you go outside of that channel and the vendor doesn't approve it, then you're suddenly irresponsible. It's kind of like the way they load the language in the terms and everything. Now, I will say, part of why there might have been a bit of confusion here, just to be a bit of a devil's advocate, um, from my reading, it seems like the initial response and the rejection of it came from HackerOne staff, not Zendesk. The researcher did try to escalate it to Zendesk, like, try to get it past HackerOne staff, and then a HackerOne staff member responded and was like, yeah, we're basically not going to accept this issue. It didn't really seem clear if they actually talked to Zendesk or if they just made that decision on their own. So there could be a bit of a disconnect there where HackerOne staff were just like, nope, letter of the law, it violates the scope, we're not accepting it. And then Zendesk was just like, oh, why would you tell other people about this?
I
And they
I don't even
might not
care,
have been looped in
honestly.
initially.
Like,
I'm just trying to say, like, that might have been part of what happened here. Obviously,
no, like
it doesn't really matter.
you're completely right. That is part of what happened. I just don't care. It's Zendesk's response in the end is to call the researcher unethical, despite the fact that it was the HackerOne researcher that closed this. It's not, oh, our policy was unclear and we do kind of care about this because like we're actively dealing with those checks and like it's supposed to be enforced. And on that note, when they did hear from the lead, since I said that I would talk about that briefly, and I guess I didn't, they do talk about the fix here where they did finally fix this after some months. And it sounds like they were using two spam filters, CloudMark and RSpam DEAP, to help determine these suspicious characteristics and will suspend emails in some cases, depending on the scores. And basically, one score was high, one score was low, and they didn't check the high score in this particular case, leading to the bug. So it was something that they were able to fix, and it was kind of on Zendesk. There's a few more details in there, but since I mentioned that I would go into that and then I didn't, I'll just toss that in now. But yeah, jumping back, the main reason I don't care here is like, even it, like Zendesk have said, like, yeah, HackerOne should have forwarded this on. We should have taken it at this point, but they didn't do that. I think it is. Like, I think the root issue here is that initial triage where it was just closes the SPF DKIM DMARC style issues. Kind of because in most cases, you're not actually dealing with an application that is dealing with emails directly like you are with Zendesk. And so a triager could just look and, make that very quick snap decision. And so, I don't even want to like harshly fault the triager here, but yeah, I do feel like that's a key part. But when they go on to be like, oh, that wasn't the issue was the researcher be acting unethically, like that is kind of thing. The HackerOne staff at one point here does mention, therefore, after consultations with the team, we have decided that this report will remain marked as informative. And I read that as meaning the Zendesk team, that they went and mediated talking with Zendesk. That seemed to be my understanding of it. I suppose it isn't that clear, but because they could have been like the rest of the H1 team or something like that. But usually when I see that language, it's referencing like they did reach out to the development team, but I would imagine their explanation of the bug very well may have been misunderstood, not appropriate given their own misunderstanding of the root issue. So yeah, I mean, even with your devil's advocate, I still think Zendesk is in the wrong for trying to call out the behavior as unethical.
I would totally agree. I don't think that's really up for argument. It seems like, and I actually just read this while you were talking, I kind of missed this on my first pass, but they state here that unsurprisingly, Zendesk didn't come out of this looking good. At least one or two companies reportedly cut ties with Zendesk after my disclosure, canceling their agreements altogether. So I guess that was kind of the source for some of the animosity there. Because the companies kind of had to take the solution in their own hands, and they had disabled Zendesk's email collaboration to protect from this issue. So I guess Zendesk kind of felt sandbagged where, these companies had forced them into acknowledging the issue. But yeah, it was it sounded like it was a bit of a shit show on all sides. And like you said, it's hard to fault the triager too much because you do kind of have that problem with bag bounties. And when you have scope like that, I really don't like the way the scope is put on a lot of HackerOne programs. But you have to kind of draw the line somewhere, and where that line is in some cases like this can be really difficult to draw. I do think it was kind of, if the HackerOne triager didn't escalate this to Zendesk because of like, when the researcher provides additional context and says like, hey, there are things that are trying to prevent this and this should be taken seriously, I would have hoped that the triager did take that to Zendesk, but given the way that I'm reading this, it doesn't sound like that happened. So that is something you could probably fault them for. But yeah, I mean, just kind of one of those funny situations where the company tries to turn it back on the researcher to save face a little bit. And, anyone who really reads through this and sees the responses can kind of see that Zendesk is basically trying to gaslight the researcher and other people into thinking the researcher was in the wrong here, which doesn't seem to be the case.
Yeah, that's like I said. There is language here that indicates they may have actually consulted with Zendesk. It is somewhat unclear because they do make mention of consulting with the team, which could be either kind of side of that in terms of
It's
team,
pretty
but
ambiguous. Yeah.
yeah. I mean, it does feel a little bit like, this is very clearly not the classic DCAM like style report that's like, oh, you don't do this. This was showing impact from the beginning. We could get access to this. And that should have
And you
set it
would kind of
apart as
hope as a
different.
triager that you would be able to tell the difference between like a
Yeah,
beg bounty
so
report and a legitimate one.
yeah, like this is showing an actual impact from the beginning of being able to add themselves onto a ticket. And they're just like, well, it depends on this, therefore it's not this. Which I don't know. I mean, the fact that it ultimately didn't actually depend on that kind of shows that wrong. I get
Yeah.
there are the complexities for the triager who would need to understand Zendesk to know that. I don't know. Like, I assume the triagers are across many, many projects and have like a quota to fill in terms of their tickets and stuff they handle. I don't know what that actually looks like in terms of what their loads look like and how difficult that is or what they're expected, but yeah, it does feel like the sort of thing that like could be a case of them just not understanding like where the application sits, because this is an application. This isn't like a web app where the application's just kind of completely removed from email. Like it is processing email directly, making it different. So yeah, I can understand the triager messing this one up, but it also like has the clear feel of a more serious issue. I would imagine though that like a lot of reports have, or a lot of reports do have people pushing back and being like, "Oh no, this is totally a serious issue. You need to believe me and just pass this on to the team." Like that does happen too, which they need to try and defend against or whatever. Like act as a mediator between, because like we were talking about the cups issue recently where the server header information disclosure thing, like the
Yeah.
researcher in that case would have been pushing that as a more serious issue, although they were pushing it because maps to a CWE, and like that wouldn't be a good issue to go to push forward, like if they were in this sort of scenario. But it is something where the researcher would be able to come back with a reasonable sounding thing, like, okay, this is like actual issue, it's disclosing this, blah blah blah. um Not necessarily as strong, but like I could understand why, because of that, they maybe do tone out or tune out a little bit. Yeah. Ultimately, like this does feel like the root cause just comes down to the triage. And if somebody at Zendesk with more understanding would have seen it, they probably could have seen like the impact and part of the issue here. I do find it interesting that they use like the incremental IDs, because that is something that's been largely like getting phased out with more random identifiers. So the fact that it's still incremental just feels like maybe just because of legacy or whatever, but I feel like they'd almost run. I guess it's probably unique to like each company, so they're not going to run out too quickly. But yeah,
Yeah, I mean they are, I guess they are somewhat constrained on like the length and character set they can use in the IDs where it's embedded in like the email, but still I feel like there's got to be some ways you can do it that are at least a little better than just incremental IDs.
encrypted
So,
ID. That way it's still incremental even, but it's encrypted, so it's
or
a unique
hashed.
value.
Yeah.
Yeah,
Yeah.
I don't like hashes for that. just because the hash then like I guess you put a secret in there and it's more or less equivalent, but at least not directly hashing it.
A hash is still, yeah, I get what you mean. If it's an HMAC hash, it would be fine.
Yeah.
If it's not, then you could still, like, if you know that it's incremental, you can just calculate what the hash will be
Yeah,
for any
although
like
I will
range of
say
IDs that are nearby.
on the engineering side, encrypted is better. Because encrypted means you get that value decrypted, you can tell immediately if this is valid or not, and then you can query using that value.
True.
Whereas with an HMAC, like you have to store the hash, the resultant hash. You can't like reverse it.
Yeah.
And so, encrypted IDs are a pretty nice solution to some of these problems, but we're going way out. Ultimately, that was not even what they decided to fix here. So you're still going to have that, which is maybe a piece of information worth keeping in mind for other issues within Zendesk. Predictable IDs. I could imagine that coming to bite them again.
Yep. Yep. It's one of those defense in depth things where it could be abused in multiple ways. So yeah, a good piece of information to keep stored away. But yeah, I mean, it's kind of an interesting scenario all around, and it is an interesting bug, even drama aside.
Yeah,
It's pretty
totally
cool
good
being able
find.
to gain access to like Slacks and stuff, and relying on email for authentication like that is kind of a problem that it seems like a lot of companies inherit from, I guess, kind of like what you said with legacy. So
Yeah, I remember a lot of panic actually. Not like it wasn't like crazy panic, but I remember like the original Ticket Trick making some waves. So it's kind of fun to see kind of return in this format. Slightly different, doing something a little different, increasing the impact in a sense. It's nice to see that sort of bug come back. It is a fun issue because it is a very logical bug that's like chaining kind of how things interact and like the layers of trust or the trust boundaries between different systems.
yeah.
It's just a fun area to have a bug in. So yeah, it's a cool bug nonetheless.
All right, so moving into our next topic, Project Zero has made a blog post titled Effective Fuzzing, a David case study. So this is about David, which is a AV1 decoder. So that's kind of why you've got that one in there. This post was made by Nick Galloway, who isn't a full-time member of Project Zero, but is a senior security engineer at Google, and kind of had this as their 20% project. So yeah, it's talking about fuzzing AV1, and they did find an integer overflow here. The vulnerability isn't particularly interesting. It's just kind of your classic int overflow. But what they wanted to talk about around it is the challenges of fuzzing and what made this issue difficult to find with fuzzing in the first place. Because ultimately, one of the parameters here that is involved in causing an overflow would require you to pass like a really large size, right? Um, and the problem you kind of run into when you're fuzzing is that you want to find bugs, but you don't want to find like useless denial of service type bugs that are caused in the harness. So if you have something where you're trying to allocate like 2 GB or 4 GB of memory or something, that's probably going to fail and cause problems in the fuzzer. So the easy solution for that, if you want to just get back to fuzzing, is to just clamp the value, right? You make it so that it has to be a reasonable-ish value. But of course, when you do that, you're then also kind of limiting what your fuzzer can do when you're clamping the values because it's not able to test the more extreme edge cases in the code. And that's kind of the whole point of this blog post, actually, is that clamping on the fuzzer side prevented discovery of this issue and limited the coverage that could be achieved by the fuzzing. So
There was another post recently, or maybe not recently, it was probably last year or something, about fuzzing. And it was the same thing where so in this case, when they're talking about the fuzzer and the fuzzer did whatever, they're talking about the OSS fuzzer. So
yeah,
Google runs like a ton of fuzzers on a ton of different projects. Whole like web scale thing where they're running so many fuzzers, and this David project was one of the fuzzers that they would run against because this is used on like Android. In like Google Chat will use it. Looks like, yeah. Oh, and iMessage maybe does. Oh no, it mentions that they're displayed in iMessage. I assume that also means they're using this library since they're mentioning it in this context, but they don't actually say it's using this library. either way, like it is like one of those sort of graphic bugs. And so this is a library that they are fuzzing and they are trying to look at for vulnerabilities. And so one of the interesting things here, I think, is just the fact that coverage isn't always going to tell you like everything, because you can cover lines of code while still not getting like good coverage on these edge cases, because all like the calculations are going to be covered but not necessarily all the possible values. And that's where you
Yeah.
start to get like value profile fuzzing, where hitting things with different values counts as a new coverage edge. And that also explodes space very, very quickly, and like explodes your number of test cases when it just takes like a different value reaching a comparison.
Yeah, your corpus like sounds like it would be hell to manage for that.
Yeah, it just explodes when you're using that. But like, it is that thing where coverage isn't the only metric, and we've talked about this many times, where it's just like coverage has been a fairly effective method, but it's not a great. We just don't have a great solution when it comes down to it.
Fuzzing
And
is
yeah,
hard
and there's a
when you're
lot of
getting into
complexities to it.
yeah.
But yeah, like in this case, like it sounds like they were able to find this bug fairly easily just by basically fuzzing with greater values than what OSS fuzz was doing. So OSS fuzz missed it, but it doesn't sound like it was too hard for them to hit this one. They did. I also found it interesting they used UBSen on to find it. Basically, so 64-bit builds of this just would not have this max size set at all, although 32-bit ones would. And so they talk about here that removing this line being that limit, because the fuzzer would define a limit, and fuzzing with UBSen enabled was enough to trigger the integer overflow. So it sounds like it was hit pretty easily, although using UBSen, which can be very, very noisy. That was one thing that actually surprised me here, was that they found it through UBSen. So UBSen, if you're unfamiliar, so ASAN is kind of the most popular sanitizer that we'll talk about, which is address sanitizer. And it's going to catch things like use after free, use after return, of course, too. It'll catch like overflows, especially on the heap. I can also set up some stuff on the stack, I believe. It'll catch those sort of things, out of bounds access,
Yeah,
wild
it's
access,
designed to catch like
like
temporal safety issues, like out of
anything
bounds
with
accesses
address. Like
and
it's sanitizing
yeah.
the address of whatever you're doing. Like that's kind of in the name there. The addresses need to be correct. It's trying to do some sanitizing on addresses of any sort of memory access. And that's generally how it works. It instruments like every read and load from memory, or every read and write from memory, or to and from memory. We'll basically get this ASAN check around it, making it impractical to run like production, but for fuzzing, it's good, and it'll catch bugs that wouldn't otherwise crash. And UBSan is undefined behavior sanitizer. So it is going to pick up, it's going to do more checks, but it's going to do more checks that are, not necessarily going to cause a crash, but might be problematic. And in this case, an integer overflow. The problem with UBSan, in my experience, is like it can be very noisy with a lot of bugs that are undefined behavior, but not problematic. So I thought it
Yeah,
was
like they don't really give you
interesting.
anything as an attacker. They don't really give you any useful primitive most of the time.
They can result, like if you let it keep running, they can result in something, like in this case integer overflow on its own could be pretty benign, but depending on how it's used, like after this it obviously leads to out of bound access. So this would have probably been caught by ASAN then too, now that I think about it, but they mention it being caught by UBSan, which I just thought it was interesting that they did it with UBSan, because I've tried playing with UBSan, unless you're like doing some really specific fuzzing and you only have like a particular thing enabled, it can get really loud and really kind of annoying, and a lot of just wasted time. So yeah, I thought it was interesting. They kind of had this fairly complex code base, which I imagine has a lot of things that are going to be undefined, or maybe they don't. Maybe this is, I have not looked at the David code, so maybe this is like really well done C, and they're never using anything that would trip UBSend, and then it's like, oh, here's something that does, and it's clearly a bug. But yeah, I don't know.
I mean,
It stood out to me.
Yeah, I was gonna say, given what we generally see as a pattern from like these parsers and stuff, I think it's reasonable to assume that it probably would have a lot of undefined behavior and a lot of flags being thrown up. But yeah, I mean, the main point of this post is to highlight those like limitations and challenges that you have with fuzzing. Another one that they call out sort of towards the end is OSS fuzz also isn't fuzzing this on ARM, and they highlight that, like, David does have optimized assembly and different code paths for different architectures. So you kind of have these gaps with fuzzing because it's difficult to cover everything. And like I said, when you're dealing with like these issues that you have to deal with at the harness level, it can be easy to do sort of mental trade-off where you're just like, okay, I don't want to deal with this and get like the max fuzzing potential possible. I just want fuzzing to get going again so that it can find other potential problems. So you just kind of, you know, monkey patch it, so to speak. Like you don't really fully try to work out the best way to maximize the fuzzing potential. So yeah, I mean, it's a really hard problem when you're fuzzing like moderately complex targets. You're trying to use like instrumentation and coverage guidance and stuff. You run into these kinds of problems, and this post is a good highlight of that.
Yeah, and this is also, I think a lot of people actually look and see, oh, there's already a fuzzer going on things, especially OSS fuzz. Therefore, and maybe take a glance at coverage and see like, oh, it's got like decent coverage. Therefore, they won't bother trying to fuzz it or won't bother trying to look for bugs there. And there are like, we've seen this time and time again where fuzzers just aren't able to reach certain bugs because they just, they might have the code coverage, but that doesn't mean they're going to be able to reach all aspects of that code. So taking the time to understand what's currently being fuzzed, like if you're looking for bugs, if you're trying to find those higher impact issues, is take a look at the existing fuzzing and figure out where it's failing, what it's not doing, what it's not looking at, or how things can be going wrong with it. Because yeah, existing fuzzing, oftentimes, especially OSS fuzz, is a lot weaker than you might expect, because a lot of the fuzzers really are just toss the randomness at and don't really have a lot of intelligence. That's maybe not the best way to put it, but they don't have a lot of thought necessarily into like the ideal fuzzing or like how to fuzz this well. It's just let's get this fuzzed at all and like get it fuzzed in the first
Yeah.
place and then worry about the rest. And odds are they focus on something more interesting than trying to improve fuzzing. That's why I'm a big fan. Like when it comes to trying to learn fuzzing, there's kind of two, there's probably more than this, but I see kind of two schools of thought on how you learn fuzzing. One is go download like AFL and just start tossing and trying to fuzz for like, a lot of times people use known bugs, so you can kind of like try and fuzz for old but real bugs, just so you know it's working, and you just kind of learn to use the fuzzer and just throw the fuzzer at everything. And the other side, I kind of step more on like understanding how fuzzing works, like all the different options and all these different things, like symbolic execution versus like different mutator options, different coverage options, like how you're going to like different metrics and all of that, and like having an understanding of the scope of things so you can be like, for this type of project, I want to fuzz in this way. Although, of course, I am reminded of the pretty classic fuzzing meme, which I never have ready when I want to bring it up, where, somebody wastes a lot of time on the fancy fuzzer and gets, no bugs, but then somebody does the dumb fuzzer and gets everything or gets a lot of bugs. So there is
On
kind of that
your
case, but my thought on learning it is like, learn the breath.
on your point of people seeing that OSS fuzz is already covering it and then kind of giving up on it, I've kind of been a victim of that before too, where I've kind of said that, like, you know, with Google, you're not really going to out fuzz or outscale Google's fuzzing capability. So you have to be doing something different. And I guess I do still kind of stand by that, because that's kind of what this post is doing, is it's showing, if you look at OSS fuzz and what it's doing and what its limitations are, if you take some time to modify that, you will catch things that it won't. And that's kind of the way I've always liked to report it, is that if you try to run exactly like what OSS fuzz is running or something, that's sort of a fool's errand, because you're going to get outscaled massively. But if you look at what can be done differently and what, like, if you can make it more context aware than what it is upstream, then you can kind of find the gaps. And yeah, yeah, that's basically what happened here.
Yeah, no, exactly that. Like, fuzzing's hard to do, and there's always places where you can improve on these complex applications. You need to look where people aren't already fuzzing. You need to find that other attack surface. And that means understanding how it's fuzzing. But yeah, a lot of times, like, code coverage isn't the best way to look at that. But yeah, as you said, you're not going to beat OSS fuzz on like scale, but you definitely can find places it is not fuzzing or it is not finding.
All right, so we'll get into our last topic here, which is Can You Get Root with Only a Cigarette Lighter by David Buchanan. So this is pretty similar to another post we covered previously. I don't remember exactly which episode. I probably should have looked that up beforehand.
Oh, that was a long time ago. So that's like
Yeah,
2022.
that was hacking Android with a lighter. Yeah. I'd have to grep through my notes to get the episode number, but the whole idea here is that a lighter can emit like a very small electromagnetic pulse. So what happens if you use that to try to do fault injection with like EMFI? Um, and they wanted to see if they could take like a laptop that's running Linux and basically take it to root with only a lighter. So they tested this on a Samsung S3520 laptop. And essentially what they went for here, which I thought was cool, was they solder an antenna to the SODIMM pin to corrupt data going across the DDR bus. So typically when you see fault injection like EMFI, it's typically going to be leveraging uh, like injecting faults in the execution engine. So you're trying to cause like an instruction skip, or you're trying to cause like there not to be enough power when something's being read or something like that. You're trying to target execution. But in this case, they're targeting, you know, addresses and stuff that are going across the bus on the pins on the RAM modules itself. So yeah, it's a really cool idea. They started out to POC this with C Python by writing a sandbox escape in air quotes via fault injection. They say in the post that, you know, C Python sandbox is not really that strong. It's just something that they're familiar with, and that's where they wanted to start with to try to test some things out. So their glitch effectively lets them flip bit 7 of a 64-bit word. And that's because they solder directly to like the DQ7 pin, which they could use to corrupt a pointer to, say, like a bytes object and make it point instead to something a little bit earlier, like the byte array object, basically causing type confusions that can be exploited. Now, of course, you know, this is easier said than done, because how do you target the glitch so specifically? When you're glitching something on a RAM module that's being used for the whole system, it's very easy for you to glitch something that you're not intending and cause like a whole system crash or something, which is obviously not what you want. So basically their idea there is just spam a bunch of transactions or accesses on the pointer to try to glitch it. Now, obviously, it can't be too naive of an implementation. You can't just like access the pointer in a loop, because if you just access the same pointer, you're going to be dealing with caching. It may not even go through the bus the same way. But they were basically able to fill an array with references to an object and then iterate through that array, which would then fetch across the DDR bus each time. And yeah, so they managed to get that to work. And after they get that POC working on the CPython escape, they wanted to see if they could then take it to root on Linux. And the way that they do this is actually pretty cool. They basically glitch physical page table entries. So instead of targeting bit 7, they target bit 29, which inside of a page table entry, those bits are used to encode the physical address. So the whole idea here is from software, they spray a bunch of level 0 page tables, which are like your bottom level, and then they try to corrupt a PTE to point to their controlled page tables instead of what the legitimate one is supposed to be. And as the write-up gets into, if you can get control over page tables as an attacker and get like arbitrary page table entries recognized, you win. Basically, you can get arbitrary read write via physical memory on the system. The kernel integrity is broken.
Yeah, and for
So
those of you who don't do like the binary level or especially kernel level stuff, like unfamiliar with the page tables and like all of that, like as Spectre just kind of mentioned, like this is kind of the core memory structure for all of memory in a sense. Um it
It's the
is a
basis of
very,
virtual memory. Yeah.
yeah, like it is the basis of how like all the programs operate. And so having control there and like doing the glitching at that level, it's a low level attack for sure. Uh, but kind of the thing to understand about that is like this is a very fundamental primitive. Once you're able to kind of inject your own entry in here, you can kind of just do whatever you want. Like, you can change code because code is all going to be in memory, so you can go and like change that. You can make it read or write, make it writable. Readable isn't so much of an issue unless you're a
Yeah.
Spectre on the PS5. But
The way I would say it is that pretty much all the permission models and stuff that the operating system is going to have is going to be enforced via virtual memory. That's how you have like process isolation. That's how you have isolation of the kernel from userland. All of that functions off of virtual memory. When you get the ability to map arbitrary virtual addresses to physical ones, um, you're pretty much bypassing all the security boundaries that are set up around that. So that's how I would put it for those who aren't super familiar with like page tables. You're basically turning it into how systems were, 40, 50 years ago or whatever, when all memory was in physical memory and just anything could write to anything on the system. That's kind of how you can get it to be again if you can control page tables. So yeah, very cool attack. And obviously it's really awesome when you see glitches like this that take advantage of equipment that's as cheap as a lighter, because that's kind of the problem you have with some of these hardware hacking kind of posts is you'll see like an EMFI setup and they have a full like nanometer precise table XY stage with like a giant emitter, and the whole setup costs like $30,000. And it's like, that's really awesome, but not very accessible for like anybody outside of hardware labs. Well, in a case like this, you know, all you need is like some solder, a wire, and a lighter. It's pretty accessible. I mean, you might fry something. It might not be the best idea to try if you're not skilled with hardware, but it's accessible, which is
don't
really
do it
cool.
on your work laptop.
That would probably be a good idea. Yeah. Um,
um, but yeah, no,
and-
it's a cool attack. I thought it was fun. I mean, of course, you're more into the hardware attacks than I am, but Gain, going with the cigarette lighter just as really cheap tool. We've talked about this sort of thing before, but it is interesting because, like you said, this can be super expensive. And so it's a place to get started as an individual who isn't going to invest thousands of dollars in the hardware.
Yeah, and I will say too that if you look towards the end of this post, um, they kind of highlight the fact that this could be practical even on like modern systems, because they had tried it here on DDR3, but there's no obvious reason why this shouldn't work on DDR4 and DDR5. Maybe it might not work on DDR5 because of like the ECC, like the error correction codes that DDR5 has.
Yeah, that's kind of what I was
Could
just
be a
thinking.
problem.
I know DDR5 has more mitigations for that sort of corruption, but not specifically that. Like it would have, because I mean the idea is like, stopping bit flips in general from like cosmic rays and stuff. So like I could imagine that happening, but I guess I just don't know enough.
Yeah. So like, these are like some of these open questions he has here are things that they want to look into. But like for DDR4, for example, like I also don't really see an issue. Architecture, like it should be fairly independent of architecture because you're attacking the memory bus. Um, and then they say like, could you use this to break out of a hypervisor? Could you write a Nintendo Switch kernel exploit for this? And like again, it seems somewhat likely that you could take advantage of this in multiple different scenarios, assuming physical access is within the realm of reasonability for an attack. So yeah,
Yeah, and
really cool research and something that could be leveraged for other things.
on that note, with physical access, like there are also a lot of attacks that are probably easier than this, in the same situations.
True.
But there
There
are
could be
some
easier
where,
avenues.
like, especially again, the console, the more locked down systems are the sort of place where physical access can be used to break some of the software restrictions. that would prevent some of the other things. Yeah, definitely
All
a
right.
cool write-up.
So, yeah, that's all the posts that we have for this episode today. So, as always, thanks goes out to everyone who tuned in. And unless you have any last minute thoughts, see, we'll wrap it up there.
No, I think that is all for this week. I think we went longer than I was expecting, but definitely some interesting topics for this week, I think.
Yeah. So, as a final bit of housekeeping, our episode for next week might be a little bit shorter than usual, as I am preparing to go to Hardware I/O on the 22nd of next week. So, time is a little bit more limited coming up. But other than that, that's only for a couple days. So, the week after should be good to go again. So, yeah. All right. We'll catch you next time.